This video is going to be the last part of Lesson 5. So we did a video for Lesson 5 on generating the unit circle. Then we did a video where we did class examples 1 through 6, and we were applying the unit circle for certain questions. And now we're going to sort of shift our focus. We're going to still be dealing with the unit circle, but we're going to do something called the equation of the unit circle is where we're going to go now. Okay, so the equation of the unit circle, it says let P, which is xy, be any point on the unit circle as shown. Okay, use Pythagoras' theorem to determine the equation of the unit circle. So we know that according to this, Pythagoras' theorem is going to be x squared plus y squared is equal to 1 squared because the radius on our unit circle is always 1. So the radius on our unit circle is always 1. So the equation then of our unit circle that we're going to use is always going to be x squared plus y squared is equal to 1. So if ever we're talking about like an equation in a unit circle, this is what the equation that they're going to be referring to is x squared plus y squared equals 1. Okay, this second part, it says we're going to figure out the equation of a circle with a center at the origin and a radius of r. So now we're going to talk about what the formula would be if it's not necessarily on the unit circle. So the unit circle has to have a radius of 1, but I could have a circle with any radius that I want. What would be the equation of that? And that would simply be x squared plus y squared is equal to r squared. So we will apply this x squared plus y squared equals r squared in class example 9. So just make yourself a note. Class example 9, we're going to apply the equation of any circle. And in class example 7 and 8, we're going to specifically be looking at the unit circle. Okay. Determine which of the following points lie on the unit circle. So I could give you any points that I want, and I could say, are they found on the unit circle? And what you would simply need to do is you have to memorize the equation of the unit circle is x squared plus y squared. If you get an answer of 1, then that point is on the unit circle. So they give me an x coordinate here and a y coordinate here. So what I simply have to do is I just have to figure out when I square each of those coordinates, do I get 1 as an answer? Okay, when I square 1 over 2, I get 1 over 4. And if I add a quarter plus a quarter, what I get is 2/4, which reduces to 1/2. That is not equal to 1. So what that means is this point here is not on the unit circle. Okay, let's look at the next point. So they give me an x coordinate and a y coordinate, and I know that x squared plus y squared, if it's on the unit circle, is going to equal to 1. So 16 over 65 squared plus, in your second bracket, it's negative 63 over 65 squared. And I'm not going to type that in. Like, you could pause the video. You could type this in exactly as you see it. Make sure that your fractions are in brackets. Make sure that your square is on the outside of the bracket. If you type both of those in and you hit enter, a 1 should come out. And what that means is this point lies on the unit circle. Okay, the last one. Here's my x, here's my y. Let's take that x coordinate, negative 2 over 3, and we're going to square it. Let's take that y coordinate, negative 5 over 3, and square it. When you take negative 2 and square it, you get 4 over 9 plus root 5 squared is simply just 5. So you could, double check that on your calculator, but the answer is 5 over 9. This would give me 9 over 9. 9 over 9 is equal to 1. Because I get an answer of 1, that point lies on the unit circle. So yes, that point's on the unit circle. Okay, class example 8. This point, so they give me my x coordinate, they don't give me my y. It lies on the unit circle in quadrant 3. So I'm going to draw this. So I know that my x is going to be negative 1/5. Okay, so my x is equal to negative 1/5. And I don't know what my y is, but I know it lies in quadrant 3. Determine the value of y for A. How would you do that? We know that if it lies on the unit circle, x squared plus y squared is equal to 1. If they want me to get y by itself, y squared is equal to 1 minus x squared. From here, y squared is equal to 1 minus x squared is negative 1 over 5 squared. Y squared is equal to 1 minus, that would be 1 over 25. And if I get common denominators, I'm going to multiply this by 25 and this by 25. Y squared is equal to 25 minus 1 is 24 over 25. And then to isolate y, we square root everything. And you have to ask yourself, the square root principle tells us that the answer would be positive and negative. But if you look in quadrant 3, the reason why they tell you it's in quadrant 3, you know that your y is going to be negative. Okay? So y is equal to negative root 24 over the square root of 5 is 5. Now what we have to do is we have to rewrite that as a mixed radical. So square root of 24 as a mixed radical would be, I'm just going to do this really quickly. This guy is a mixed radical, would be 2 root 6. So I'm just going to erase this, and my y coordinate is going to be negative 2 root 6. So negative 2 root 6 over 5. That's what my y coordinate is. So on my unit circle, I have that this radius would be 1, and my x coordinate is negative 1/5, and my y coordinate is negative 2 root 6 over 5. That's what my y is. Okay, now that I have x, y, and r, they are saying, well, please tell me point P lies on the terminal arm of rotation angle theta. Okay, so point P was right here. And what they want is they eventually want what the rotational angle will be. So we're gonna have to figure out what that angle is. And then they're saying determine the exact values of secant theta and cotan theta. So, okay, let's do this. Say to yourself, secant theta, what is that the reciprocal trig ratio of? So secant theta is the reciprocal trig ratio of cosine. So if you said to yourself, well, what is the cos of theta? We know that the cos of theta is x over r, right? Or it's your x coordinate. That's what the cos of theta is. So my coordinate, because it's on the unit circle, um, x over r would just simply be what my x coordinate is. So the cosine of theta is negative 1 over 5. Okay? If you know what the cosine of theta is, we know what the secant of theta is because they are reciprocals of one another. So the reciprocal of negative 1/5 would simply be negative 5. So the secant of theta is negative 5. Okay, then it wants the cotan of theta. So before figuring out the cotan of theta, I always say, well, what's the tan of theta? Tan of theta is y over x. So I go up to what I figured out, and y was this number here. So negative 2 root 6 over 5. Instead of dividing it by x, so instead of dividing it by this, I'm going to multiply it by the reciprocal. So I'm going to multiply it by negative 5 over 1. What you will get is your 5's will cancel. We've got two negatives, which is going to give us a positive. And I am simply going to have the tan of theta is equal to 2 root 6. If I know that that's the tan of theta, I could easily find what the cotan of theta is, because the cotan of theta is the reciprocal of the tan of theta. And if that's the tan of theta, then the cotan of theta, maybe I'm going to write it up here because I'm going to have to do rationalizing. The cotan of theta would be 1 over 2 root 6. And then we got to get rid of that root 6. So we need to multiply numerator and denominator by root 6. And what we would get is the cotan of theta is equal to root 6 over 2 times 6, which is 12. And that would be your answer for what the cotan of theta is. Okay, the last question for this class example was C. Determine the value of theta to the nearest tenth of a radian, and they tell us we need to be in radian mode. So first of all, I'm going to go to my calculator. I'm going to confirm that I'm in radian mode. In order to figure out what your radian modes are, okay, so in order to do this, here's what I'm going to use. I'm finding the inverse of one of these ratios, and because I have cos written here, I'm going to use cos. Because remember, I have to either choose cos, sine, or tangent. I could have used tan as well. I'll show you that we'll get the exact same answer if I use tan. But I'm going to use the cos of theta is equal to negative 1 over 5. So if I was finding an angle, you'd use the inverse of that function. So it's the inverse cos of the absolute value of this, which would be 1/5. And what that would give us would be our reference angle. So let's see what we get. Second function cos of 1 divided by 5 gives me an answer of 1 point, let's see, I'm just going to look, they say to the nearest tenth. So I'm going to actually write a few decimals and we'll round at the end. 1.369, I'm going to write. And remember that when we do this, that always gives us our reference angle. I'm just going to show you how we would get the exact same answer if you would have chosen to do tan, right? So if I would have chosen tan, the inverse tan of 2 root 6 gives me the same reference angle. I could have even done sine, right? So I know that my sine of theta is equal to my y value. So if I do the inverse sine of this guy, you would get the same reference angle. But I used cos, that's my reference angle. What quadrant were we in? Going back up here, we were in quadrant 3. So let's put that reference angle in quadrant 3 and then determine the rotational angle. So in quadrant 3, that reference angle would be right up here, 1.369. The rotational angle is going to be pi plus whatever your reference angle is. So on my calculator, pi plus that answer gives me 4.511, and here I could round to the nearest tenth, which is 4.5 radians. So my answer is theta is equal to 4.5 radians. Okay, we have one last class example for this question, and this is going to be on that second equation. So the first equation was on the unit circle. So remember, if we're on the unit circle, it's x squared plus y squared equals 1. This says determine the equation of a circle with a center at its origin and a radius of 8. So radius of 8 means that we're not on the unit circle, we're on a bigger circle. So what we would do is we would say, okay, the equation of this circle is x squared plus y squared is equal to, remember it was x squared plus y squared is equal to r squared, and r is 8. Okay, so that would be x squared plus y squared is equal to 64. That would be the equation of a circle with a radius of 8. That would be your equation. If this point lies on this circle here, right? That's the equation of my circle, and this point lies on it. Determine all the possible values of b. So they give me a point, and I know that that's an x-coordinate and that's a y-coordinate. I have to plug that in into the equation of this circle. So that would be negative 4 squared plus b root 3 squared is equal to 64. Negative 4 squared is 16 plus b squared, and then root 3 squared is just simply 3 is equal to 64. I'm going to rewrite this. So 16 plus, I want to put this as 3b squared is equal to 64. From here, it said what is the possible values of b. So I'm going to subtract 16 from both sides, and I would get 3b squared is equal to 48. Divide both sides by 3, and you would get b squared is equal to 16. Take the square root of both sides and apply the square root principle, and you would get b is equal to plus or minus 4. And that's how you do that question. So what I have for homework, the following questions: 1, 2 to 4 ACE, 5 to 8, 10 to 15.